Hey guys, welcome back to the channel. My name is Ezekiel Morales. I'm a production engineer here at Lord Technology. And today we have a special demo for you guys. That is a stereo vision camera from IDS. It is an Ensenso N36. And what we're going to do today is kind of briefly talk about some features and some applications that this can be used for. So let's go ahead and get started. All right, first off, once your camera's all connected and powered on, we're going to go ahead and open up NX View. And then if your camera is connected to your network and set up properly, you can go ahead and click on that one. For here, we have the N36 kit, the blue light. We go ahead and click open. And then we're gonna go ahead and actually move this a little more up. All right. Now, since we did move a little bit the working distance, we're gonna go ahead and just recalibrate the workspace just to make sure we get all the data correctly. So what we're gonna do here is get a calibration plate. And we're gonna put it on our table here for you. All right. And then to do that workspace calibration, the interface is very, very useful and helpful. So right here on the under operation mode, we're gonna go to workspace calibration. And then we're gonna do set origin with calibration plate. Click on that. And then we're gonna go ahead and click start. It's gonna take a couple of images, calculate the pattern. It's gonna store that within the camera. And then now it knows that this is our workspace. So now when we go ahead and go back into here, as you can see, it is our table. Now, if we're wanting to do a part finder, we're gonna go ahead and click on tools, go to part finder, and you'll get this pop-up. So you might be asking why part finder? Why would you need this tool? It is a very special package, software package that comes within NX View that does take additional licensing, but a key feature and a benefit is that you're able to do bin picking, for example. So say the Ensenso is mounted on a robotic arm, and that robotic arm needs that data to understand what part it needs to pick out. So that's what we're going to show here, that feature. So once you open up Part Finder, the first thing we're going to have to do is upload a CAD model. Here I have an STL file, so we're going to go ahead and click these three little dots. Go to here, I have the download. I have the file here, it's called a 1/2" PVC clip. Go ahead and click open. And since I already have this model uploaded, so nothing much changed, but here we see the different views of that specific CAD model. And then you can change that view if you need to minimize the position, so the points. So you go here, the viewpoints, you're gonna go ahead and do rotation symmetric, x-axis, y-axis, or only a specific direction. But for this example, we're gonna go ahead and do all points. Once we're ready for that, go ahead and create model. So it's gonna create model in point cloud, and it's gonna get all these data from all these different angles. And then we're gonna go ahead and leave all this information, we'll just leave it by default. Go ahead and click find model. Now it was able to find 3 models. And it gives it the score. The first model here, as you can see, it gave this one a score of 87. And then the next one, highlighted in blue, light blue, is 83. And then lastly, this will give it a score of 64. Now we can go ahead and readjust this one just to see if it gets a better score. And once again, you can click on find model, and it gives you a better score. Now going back to the example of me saying about bin picking and mounting this on a robotic arm. So the Ensenso camera is going to get all this 3D data, and it's going to be able to communicate that to the robotic arm to find the position, the XYZ of that specific part. So for example, 0.87. So give it a score of that. You have the X, Y, and Z coordinates, and it's going to go ahead and tell that to the robotic arm and move to that position and pick up that part. Same thing, once that one's picked up, it goes to the next one. So it can be programmed for picking the highest scored one because it knows that's the most accurate. And another example that I want to talk about is even for, I know I mentioned defects on a part. So say for example this one, let me see if we can set this one up. We're gonna go ahead and cover this one, this other piece, and we're going to go ahead and do a find model. So this one's a very low score. So say for example, the score was very low, then that means that all the 3D data wasn't accurate, and there could be an actual defect on that part. So that also helps, sorting out the good parts and the bad parts. Makes life a little bit easier. Now, you can go back to the setup, and here under minimal final score, you can increase it to, say you want something just 75 and greater. So we're gonna go ahead and move that. So when you go ahead and click find model, now it's not gonna find the other two. Why is that? Because we increased our tolerance to 75, a score of 75 or higher. So now the only thing that's gonna pick up is this one right here. Now let's go ahead and move this back to 50. And then another key thing is, even here in this example, we only have three parts that we're looking for. Say you have a big bin of 100 parts. Then in your cluster count, you can go ahead and increase that as well to 100. Or so when you increase that to 100 or whatever value you want, it's gonna go ahead and just, we only have 3 parts here, but this list is gonna go up to 100 or to that count you set it up to. So that way you don't feed so much information to that robotic arm. It only tracks a certain specific one before it moves on to the next. So I do want to note that the Part Finder software module does require a separate license. So if you have any questions on pricing or you just want more information on the tool itself, please don't hesitate to reach out to us at sales@lordtech.io, and we will be more than happy to help you out with any questions you have. Thank you. Have a great day.